Hi everyone, welcome to InfosecTrain. This is Ashish Dhyani, and today in the cybersecurity month of October, we will be starting about learning about your spanning tree protocol. Now, what is spanning tree protocol, guys? If you will learn about spanning tree protocol, so spanning tree protocol is a protocol that will help you in removing the redundant links. Now, what is a redundant link, guys? As you can see in this topology, what we have this switch, we have these three switches. Now, if I want to go, let's say I want to go towards PC of this with the name Arvind. So what I have, Mr. Amlendra, the first person, he can send the data to switch 1 can send data to switch 2, and switch 2 can send the data to switch 3. This is the one path. The second path can be switch 1 will be sending data directly to switch 3 and it will be getting by Mr. Arvind. So this is a redundant link where you have more than two paths to reach one destination, right? Now, the thing is, when we have two paths, now what we are assuming, let's say, uh, this, this link of Mr. Arvind, this due to some reasons, this link becomes faulty, right? Now, what is the working of a switch? If we know switch is a smart device and it stores the MAC addresses attached to the port numbers, right? So it sends data directly to the person where that data is intended for. But right now, switch is directly connected to the switch, not the device. It is only connected to one device. Every switch is connected to one device, right? Now, I'll tell you a thing that will be very precious about switch, that when switch does not knows where the device is, when the switch does not knows where the device is, it just works as a hub, it broadcasts the data. So as we discussed, like, let's say our this link is not working. So what if Mr. Amalendra want to send data to Mr. Arvind? So Mr. Amalendra will send his data to switch 1, and switch 1 will do what? Switch 1 do not knows where your switch 2 is or your Arvind is. He just knows that there are two wires connected to me. He will just broadcast the data towards these two wires, right? Now the data will reach to switch 2. Mr. Switch 2 will do what? It will just find out, it will check its cam table that whether anyone with the name Arvind connected to me. It will say no, and it will just directly forward that data to a switch 3. Same like that, switch 3 will get that data and it will forward it. Now that data will create a loop in this topology. Now, what if Mr. Amalendra is sending not only one packet, but he's sending 1000 packets towards Mr. Arvind, and Mr. Arvind is not connected to the network? What will happen then? Now, what will happen? The data will be looping around. Now, that's fine. It is looping around, but what is happening? Let's see it from the scenario of switch 2. Switch 2 has a cam table, and if you guys know, so cam stands for content addressable memory table, right? So content addressable memory table has your MAC address and the port number. So it has only one port connected. So port FA02 is connected to the, let's say the MAC address of Mr. Arjun is A1R1, right? So it has only this thing. Now what it will do, switch 2 will get the data from switch 1 and he will say, that Mr. Amalendra. So Mr. Amalendra AM1 is connected to port number GI02, right? Now what will happen? It will save it in its CAM table. But what will happen? Switch 1 is doing what? Switch 1 is also sending data towards switch 3. When switch 3 will get that data, switch 3 will forward that data towards switch 2. Now switch 2 will do what, guys? Switch 2 will directly change its CAM table. It will modify its CAM table and it will say, no, my Mr. Amalendra is not connected to GI02. Mr. Amalendra is connected to GI01. Again, that will be happening because Mr. Amalendra has sent 1,000 packets. With every packet, this thing will be happening, and after a time, this switch 2 will crash. Right now, this switch 2 is crashed. With this switch 2, we are only taking care of switch 2. What will be happening with switch 3? Switch 3 will be also getting crashed. Switch 1 will also be getting crashed. Now, when all these switches are getting crashed, that means there are redundant links that should be removed. We have to remove these redundant links. Now, who will help there? Spanning tree protocol will help there. Now, spanning tree protocol works in 3 steps. First is elect root bridge. Now, guys, bridge here means switch, right? Now, second step, elect one root port per non-root switch, right? And the third step is elect one designated port. Now, root bridge, what happens? Root bridge is someone, let's say switch 1 is the root bridge. So only root bridge will be forwarding the data, no one else. So root bridge is the bridge who will be forwarding the data to everyone, right? Now, how we will elect the root bridge? We have some decision process, right? So we have something with the name decision process. So in decision process, if we talk about, we have to first find out lowest bridge ID. We have to find out second thing, lowest root path cost. And the third thing, lowest sender bridge ID. Again, I'm reminding you guys that bridge means switch over here. Now, lowest sender port ID is the fourth thing. These four things are the decision process, how we will elect the root bridge, root port, and designated port, right? So these are the things. So for example, if I tell you, so lowest bridge ID means we will discuss about the lowest. Let's say switch 1 has MAC address of AAA, switch 2 has BBB, and switch 3 has CCC. So what will happen, guys? Anyone having lowest MAC address will be having lowest bridge ID, right? So switch 1 has the lowest MAC address, which is AAAA. And how it is lowest, if we talk about it, so in hexadecimal form, 0 to 9 are the numbers, and 10 is called A. 11 is called B, and 12 is called C. So 10 is the lowest one. So that's why switch 1 is the root bridge, right? So that's why what happens when root bridge will be sending the data, all the data will be there, right? All the data will be received by all the switches and it will be forwarded. Now, what happens after the implementation of your spanning tree protocol? What will happen, guys? Your one of the link will be closed. Like, let's say this link is closed. So, if there is no one in this side and no one in this side, again, we are taking the example that Mr. Arvind is not connected. So what will happen? The date switch 1 will forward the data towards switch 2 and switch 3. They will not find out. They don't have any place to forward it again. So the data will not be continuously looping around in the topology, and it will be never crashing the switches, right? Now, this is the thing about spanning tree protocol, that how spanning tree protocol stops the things. It will just find out that whether the things that we are using, whether the things that whether the topologies we are using, are those things helping us, are those things harming us or not, right? Now, if we talk about more things in spanning tree protocol, so in spanning tree protocol, what do we have? We have the process, but before the process, we have BPDUs. Now, BPDUs are what? Bridge Protocol Data Units. Now, what happens, guys, when you switch on all the switches, the first thing that is transferred before the data transfer, those are your BPDUs. Bridge Protocol Data Units. Every BPDU is sent every 2 seconds, right? So every 2 seconds, one BPDU is generated in every switch, and every switch sends that BPDU towards the other one. So if any switch finds out that, let's say, the BPDU of switch 1 carries the MAC address of AAAA, and it was sending it towards switch 2. So switch 2 will compare it with its MAC address, and it will find out that my MAC address is greater than the switch 1's MAC address. So I will stop sending my BPDUs and I'll send the BPDUs. I will forward the BPDUs of switch 1. Same like that, when it will send it towards switch 3, switch 3 will find out that my BPDU is greater than the one of switch 1. So I will stop manufacturing my BPDUs and I will forward the BPDUs of switch 1. When this process is done, then your switch 1 is your root bridge, and then your data transfer can happen, right? So that is the working of your spanning tree protocol, which is helping you in finding out redundant links and in helping in closing the redundant links. So thank you everyone for having this, and this is about your spanning tree protocol. We'll be back with some more videos. Thank you everyone. Thank you so much.